So we're discussing a new section, section 12.3, and we're going to look at measures of central tendency of data sets. Our objectives in this section are to compute the mean of a data set, compute the median of a data set, compare the properties of mean and median, and find the mode of a data set. We'll also be looking at percentiles, and in particular Q1 and Q3, which are quartiles. So for a quantitative variable, a variable that has measurements, one of the central measures is called the mean, or arithmetic average. The mean is the sum of the values of the variable divided by the number of observations of the data set. So in the example below, we are looking at the following. We're looking at the example of 5 different data sets: 68, 78, 83, 85, and 92. And the mean value we found, if we add those numbers up and we divide by 5, we get 81.2. It turns out that this particular value is the mean of the sample. So there are two ideas. There is the mean of the population, which is called a parameter, and there is the mean of the sample of the data set, which is called a statistic. The math equations to find the mean for the population of the sample are as follows. For the population, the equation for mu, which is the population mean, is equal to the sum of all the values in the population divided by the size of the population. The sample, which is the data set, which we call x bar, is nothing more than the sum of the values in the sample divided by the sample size. So here is the sample mean. A second measure of the center of the data set is called the median. This measure is the center value of the variable's sorted data set, or the middle value. The median is found by sorting the observations of the variable in increasing value and choosing the middle value. If the data set has an even number of observations, then the median is the average of the two middle numbers. If it is odd, it is just that middle number. So an example of finding the mean and the median of a data set, we look at 8 patients that undergo a new surgical procedure, and the number of days spent in recovery for each are as follows. Find the mean and the median of the number of days of recovery. So our values are 20, 15, 12, 27, 13, 19, 13, and 21. The mean value is we add up all the values, 20 up through 21, and we sum them up and we divide by 8. So that number here is this, x bar, and we get 17.5. If we sort the data set from large from small to large, we see that the two middle values in this particular case are 15 and 19. We add those two together and we divide by 2. When we do that, we get the median to be 17. So now we have the mean value, which is 17.5, and the median, which is 17. Since both the mean and the median are measuring the center of the data distribution, comparison of the two measures help us understand how measures are being affected by extreme values. For example, if the median is at the same location as the mean, the distribution is typically symmetrical, which we call almost normal. If the median is less than the mean, then the center is being pulled to the right. It is skewed right. If the median is greater than the mean, then the center is pulled left and it is skewed left. So in the examples on the side here, we have the example, this is symmetric, this value here is skewed right, and this is skewed left. The mode is the most frequent value in the data set. The mode helps us to understand the nature of the data collected based on the variable. The mode value can be used in both quantitative and qualitative data sets. The shape of the distribution can be determined by the distribution's mode. In the previous chapter, we saw the difference between unimodal and multimodal distributions. For example, 8 patients undergo a new surgical procedure and the number of days spent in recovery is each as follows. Find the mode of the number of days in recovery. So in this particular case, the most frequent observation we find is 13. No other day happens to be the most frequent, so our mode is 13. Because outliers may affect the mean and standard deviation statistics, other non-parametric statistics are used to understand a variable's distribution. Besides the mean, median, the quartile statistics breaks the distribution into fourths. The first quartile, designated at Q1, is the point where 1/4 or 25% of the distribution is below Q1. The third quartile is designated at Q3 and is the point where 3/4 or 75% of the data is distributed below Q3. So computing the quartiles, there are several methods for computing, all of which give similar results but may be slightly different. The following procedure is one fairly straightforward method. Arrange the data in increasing order. Let n be the number of values in the data set. To compute the second quartile, simply compute the median. For the first or third quartiles, proceed as follows. For the first quartile, compute L to be 0.25 times n. For the third quartile, compute L is equal to 0.75 times n. L is standing for location. So if L is a whole number, the quartile is the average of the numbers in position L and the number in position L plus 1. If L is not a whole number, we round up to the next whole number. The quartile is the number in the position corresponding to the round up value. So in our following examples, find the following data and show the HDL cholesterol levels of 8 patients. Find Q1, the median, Q3, and in this sorted data set. So we have our data set. We have 8 patients, and their HDL cholesterol levels go from 27 on up to 80. So our Q1 location is 8 times 0.25, which is 2. So we average positions 2 and 3, which is 36 and 37. right? So when we look at this, we get 36 and 37. We take those two numbers and we divide by 2, and Q1 is 36.5. Our median location, of course, is nothing more than n plus 1 divided by 2, which is 4.5. So the median is the average between 63 and 53 and 63, and we divide it by 2 and we get 58. Finally, we're going to get Q3. We multiply Q3, 8 times 0.75, we get 6. And since it's a whole number, we average the positions in 6 and 7, so that we add 64 and 74 and divide by 2 and we get 69. So in general, in finding the percentiles, we just multiply the percentile, which in this case, if it's Q1, is 25%, times n, and then use the methods for either rounding up to the next position number, or we average the two positions numbers. Now that we know how to do quartiles, we have what's called a 5-number summary, and our 5-number summary is the minimum number in the data set, Q1, the median, Q3, and the maximum value. Well, this concludes our section 12.3, which is on the center measures of our data distribution. And our next chapter, we will be discussing the spread of a data distribution.